Hi, I'm Mary, and this is another magical math moment. This video is designed for Algebra 2 students and could be a review for pre-cal kids. Algebra 1, this probably is not for you unless you want to be terrified. Just kidding, it's really not that bad. This is part 2 of solving log equations, so it's going to get a little more complicated in these problems. We're just going to jump right in. So the first thing that we're going to have to do is condense where we can. After that, we're going to solve using the strategies that we used in part 1 of the video. So if you've got logs on both sides, they can cancel. Otherwise, isolate the log expression and convert it to exponential form. Okay, so here we have log base 3 of 48 minus log base 3 of x equals log base 3 of 4. When we're subtracting with logs, that means I'm going to have a fraction when I condense it. So I have 48 on top, x goes down to the bottom. The reason the 48 stays up is because this term is positive, this term is negative, so the x moves down. And that is equal to log base 3 of 4. Okay, so since I have log base 3 on both sides, these two things have to be equal. So I have 48 over x equals 4. Now, I'm going to offer you a little shortcut. It's something I call switcheroo. So if you've got a variable on the bottom of a fraction like this and it's equal just to some thing over here, you can swap these out and that's going to save you some time. Oh gosh, I just recopied the whole darn thing. There's 4 is x. Now I've got 48 divided by 4. We all know that's 12 and we're done. Now in case you're like, wait a minute, what did you just do? I don't think I buy that. If you go over here and work it out algebraically, so I would put that 4 over 1 so that you have a proportion. Is that on there? It is. We're going to cross multiply. So 4 times x is 4x. 48 times 1 is 48. And then you're going to divide by the 4. So x is 12. So not a whole lot more work this way, but if you're taking a standardized test and time is of the essence, this is a nice little way to save some time. So switcheroo. We also do have to check this because it's a log equation. So we're going to throw it in our x value of 12 in here. So we have log base 3 of 48 minus log base 3 of 12, and that should equal log base 3 of 4. Okay, let's see what this is going to give us. So math alpha math, I've got a base 3, 48, and then I'm going to subtract from that my other log expression, log base 3 of 12. And I get 1.262. I'm also going to evaluate the log base 3 of 4. Oh my gosh. I'm going right to the log button. What am I doing? Hey, it's the same thing. Okay, so it worked out and we're all good. 12 is a valid solution. Let's make it a little more complicated. Okay, so in this one, we are adding, which means I'm going to be multiplying these things. So I now have log of x times the quantity x plus 3. That equals log 4. All right, they both have a common base of 10 here, so we can kind of cancel them out. I can go ahead and distribute this in, so x squared plus 3x equals 4. Oh, look, it's your favorite type of equation, quadratic. We're going to set it to 0 by subtracting a 4. And now I've got to figure out the factors of negative 4 that add to positive 3. So how about 4 and negative 1? 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. Remember, when you're setting each of your factors to 0, essentially, that's just going to change the sign when you solve them. So our solutions are negative 4 and 1. Oh boy, we have 2 answers to check. Who's excited? I know, I can hear the moans hypothetically here. So I have log of negative 4 plus log of negative 4 plus 3, and that should equal log 4. Can I fit it? Yes, I can. Now, I hope that when you're looking at this, you're saying, wait a minute, I can't take the log of a negative number. It won't let me do that. So once you're here, we know that negative 4 can't work. let's try 1 and see if that works. Log 1 plus log of 1 plus 3 equals log 4. All right, log 1. Let's see if we can get that. Log 1 plus the log of 1 plus 3 equals 0.205. Log 4 is not that. Oh, I typed this wrong. Oh, lady, what are you doing? This is actually good. So if you make a mistake in your typing, like I did, I forgot to close off the parentheses, you can go up and copy this, and then you can go back to where you made your error and hit second delete, which allows you to insert anything you want. So I'm gonna put my closed parenthesis there. Hey, there we go, that's better. 0.602. And that's what we got for the other side as well. It checks out. So my only solution for this one is 1. Nice work. Okay, now we have ln. Ooh, log base e. I've got a number out front. Hopefully you remember that's going to come up as an exponent when I condense this. So we have ln of 2 to the third minus ln 4 equals ln x. Since I am subtracting, I know I'm going to have a fraction. 2 to the third is 8. 4 goes down to the bottom. That's equal to ln x. The ln's are going to cancel. 8 divided by 4 is 2. So x should be 2. But of course, we have to check this and make sure it works. So we have 3 ln 2 minus ln 4, and that should equal ln 2. All right, let's see if it does. 3 ln 2, close your parenthesis, minus ln 4, close your parenthesis, and I get 0.693. ln 2, woohoo, 0.693. There we go. X does equal 2. All right. Ooh, this is a weird looking one. So I've got 1/2 ln x minus 2 ln 2. There's a couple ways you can do this. I think what I would do, since they're both ln, I would probably move this term over. So I would start with 1/2 ln x equals 2 ln 2 over there. All right, from there, I would bring this 1/2 up as our exponent. So this is ln of x to the 1/2. And then 2 is gonna come up here. So this is ln of 2 squared. Since they're both ln's, they cancel. I'm left with x to the 1/2, or the square root of x if you prefer. 2 squared is 4. To solve this, we're going to square both sides. So x equals 4 squared, 16. Okay, let's check it and see if it works. I have 1/2 of ln 16 minus 2 ln 2. All right, I've got my substitution. I'm gonna put 1/2 as 0.5 just so it's easier to type. 0 equals 0. That is true. X does equal 16. Awesome. All right, look at this foolishness. I have logs on this side, but not that. So I have to condense over here on the left side first. I'll keep my log base 5, and then I know I'm going to be multiplying these two things. I'm gonna FOIL it out, so I'm gonna end up with x squared plus I have a 1x and a 4x, so a 5x in the middle, and then 4 times 1 is 4 at the end, and that equals 2. Okay. The log expression is isolated, even though that's kind of disgusting. We're gonna go ahead and convert it to exponential form. The base is 5, the exponent is 2, and that's equal to this whole thing, x squared plus 5x plus 4. 5 squared is 25. Since this is a quadratic equation, I'm gonna go ahead and subtract the 25 on both sides. Yeah. So now I have x squared plus 5x. 4 minus 25 is negative 21. Yay, we get to factor. All right, factors of negative 21 that add to positive 5. How about 7 and negative 3? 7 times negative 3 is negative 21. 7 minus 3 is 4, not 5. Ooh, so this one's not going to factor. Oh, that's so disappointing. I was hoping we'd have something pretty, but we don't. There are no other factors of negative 21 that'll combine for us. Oh no. You know what that means. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Quadratic formula. How fun. Negative 5 plus or minus, let's see, 25 plus, what's 4 times 21? 84 over 2. Oh my goodness. Negative 5 plus or minus 84 plus 25 is 109 over 2. Is 109 prime, I wonder? I think it might be. Let me try 7. No. 109, 11. No. I'm just dividing by some numbers to see if anything works. No. It does not. Okay. So sadly, that's kind of where we end up, which is disgusting. So when we are checking this, we would have to substitute this back into the original equation. Isn't that terrible? I would go ahead and figure out what this is as a decimal though, just to make life easier, because otherwise you're going to be real upset. So let's see. I've got negative 5. Let me get rid of this nonsense for you so you can watch what I'm doing. Actually, I'll stay over here. You see what I'm doing? Yeah, you can see what I'm doing. Negative 5 plus the square root of 109 divided by 2 is 2.720. So we'll just say that. I can also do negative 5 minus square root of 109 and then divide that by 2. Negative 7.72. All right, so since we are approximating with our answers here, we're not going to have things exact when we do our check, but that's okay. So we've got log base 5 of 2.72 plus 4 plus log base 5 of 2.72 plus 1, and that should equal 2. Holy cow. Log base 5 of 6.72 plus log base 5 of 3.72. I don't like these decimals. All right, let's see if it works. What do you think? You think it's going to work? I honestly have no idea. Let's see. Log base 5 of 6.72 plus log base 5 of 3.72 is 1.99996. So we're going to say that's 2. Woohoo! Good enough. We also have to check the other thing. So we have log base 5 of negative 7.72 plus 4 plus the log base 5 of negative 7.72 plus 1. That should equal 2. Oh my gosh. Let's see what this is. I think rather than try to calculate it, I would, once you have that, just throw it in. Why make an arithmetic error? Because that's really what would happen here, especially to me, especially at this hour of the evening. All right, let's see. Negative 7.72 plus 4. So I can just leave that like that. Plus another log expression. Come on. Log base 5 of negative 7.72 plus 1. Uh-oh. It won't let me do it. Why won't it let me do it, you ask? Oh, look, because this negative in here. I guess we should simplify that so that you can see it. Negative 7.72 plus 4 is going to give you negative 3.72. That we cannot do. So the only solution that works for this one is that 2.72. Remember, you can't take the log of a negative number. That's why it's so important when you're doing these that you work them out. Now, that's not to say you can't get a negative solution. It just depends on the problem. So don't get something like x equals negative 1 and say, oh, it doesn't work, because it might. You just don't know. It depends on what the problem is. So just be careful of that and always check your solutions. I hope that this has been helpful for you. And if you've liked this video, please hit like, share with your classmates, and subscribe. Thank you so much for joining me. I'll see you next time. Bye.